This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. AIMS 2014, which says that a particle moves along a curve of unknown shape but magnitude of force is constant and always acts along the tangent to the curve. Then you have to find out whether the force is conservative, non-conservative or what. So four options are given. So basically if the object moves through any shape and force is constant but it is directed along the curve, directed along the tangent to the curve, so the direction of force will not be constant. The direction of force changes as per the direction of curve. So in this case the work done by force will not depend only on the final point or the initial point, but it depends on the path also. Like for this, the direction of force will be along this curve. For if I move through this path, then at any point the direction of force will be along the curve. So clearly the direction of force is not constant. So you should keep in mind that for conservative force, this is a very important concept. For conservative force, direction of force will be constant. Direction of force is constant. If the direction of force will be constant, then it is a conservative force. While for non-conservative force, the direction of force depends on the path. So for non-conservative force, direction of force depends on the path of motion. So here the direction of force acts along the tangent to the curve, so it's changing and along the path of motion, so F must be non-conservative force. So we will see second problem. It's from the AIMS 2005 and it is assertion region based. First assertion is that frictional force are conservative forces, and the reason is that potential energy can be associated with frictional force. So first statement is clearly wrong. Frictional force is a non-conservative force, we have already learned, and the reason which is given that potential energy can be associated with frictional force. Potential energy cannot be associated with frictional force. It will be associated only with gravitational force, spring force or any other conservative force. So both assertion is wrong, reason is wrong. Now we will move to next problem, and this problem is that a particle of mass 0.01 kg travels along the curve with velocity given by 4I plus 16k meter per second. After some time its velocity becomes equal to 8I plus 20j meter per second due to the action of conservative force. The work done on particle during this interval of time. See, if you see that this problem, it's very easy problem, that the velocity is given, v given, initial velocity is given, final velocity is given and mass is given, and you have to calculate the work done on the particle during this interval of time. So clearly you have to apply work energy theorem. So final velocity v is equal to 8I plus 20j, and so if we take the magnitude of v, if we take the magnitude of final velocity, then it is equal to 8 square plus 20 square, and it is 64 plus 400, that is square root 464. Similarly, the initial velocity u is equal to 4I plus 16k, and if you take the magnitude of this initial velocity, if you take the magnitude of this initial velocity, then it is equal to 16 plus 256, that is equal to square root 272. Now you calculate the change in kinetic energy. Delta k is equal to 1 by 2, m is equal to 10 to the power minus 2, and v square minus u square is equal to 464 minus 272. So So 464 minus 272. So the value is equal to 1 into 10 to the power minus 2 into 29192, and the value comes equal to 96 into 10 to the power minus 2, that is 0.96 joule. So change in kinetic energy is equal to 0.96 joule, and it must be equal to work done by the conservative force during this interval of time. So answer will be 0.96 joule. If you see the option, answer will be D. Now we'll see one problem of level 2, and this problem I have picked from AIPMT 2000. AIPMT 1998, and the problem says that if x is equal to 3 minus 4 t square plus tq, then the work done in first 4 seconds will be. The mass of particle is given, x is given, you have to calculate the work done in first 4 seconds. Again, you just apply work energy theorem, that W is equal to delta kinetic energy changing, and x is given. If you differentiate it, you will get the velocity. So x is equal to 3 minus 4 t square plus tq. Differentiating it, we get dx by dt is equal to minus 4 into 2t plus 3t square and minus 8t plus 3t square. Now you just put the value of t is equal to 4 seconds, we get the velocity at time t is equal to 4. So for t is equal to 4, we get velocity at t is equal to 4, and the value is equal to minus 8 into 4 plus 3 into 16, or 48 minus 32. So 16 meter per second is the velocity of particle after time 4 seconds. Mass of particle is given, so if you get the final kinetic energy, then half mv square, half m into v square is equal to 256, and the value comes equal to 128 into 3 into 10 to the power minus 13 joule, and it is equal to 384 millijoule. So this is the change in kinetic energy, which is equal to 384 millijoule. So the work done will be equal to 384 millijoule, and answer will be first. Second problem is that this is also very good problem, which gives you an idea about the work energy theorem even more in detail. And the VT graph and object of a mass m is shown in this figure. You have to identify the correct statement. If you see this figure, then the velocity increases from 0 to 20 meter per second for the time period 0 to 20 second, and from the time 20 to 30 second the velocity decreases to value 0. So first statement is the work done on the object in 30 seconds is 0. So if you consider the full duration of 30 seconds, then change in velocity delta kinetic energy is equal to 0, as half mv square. Final velocity is 0, initial velocity is 0, so change in kinetic energy is 0. So work done by object in 30 seconds will be 0. So this statement is correct. If I consider the time period 0 to 20 seconds, considering the time period t is equal to 0 to 20 seconds, then work done will not be equal to 0. So for I just make a note here that for time t is equal to 0 to 20 seconds, work done is equal to half into m into v square. V square is 20 square. This will be the work done, and it is not equal to 0. But for the 0 to 30 seconds, the work done will be 0, as the total change in kinetic energy will be equal to 0. Second statement, the average acceleration of object is 0. So for average acceleration, we know that A average is equal to V final minus V initial but divided by delta t. If you have any doubt about average acceleration or how we calculate this value, you just go through my notes in motion in a straight line to get an idea about it. So final velocity is 0, initial velocity is 0. If I divide it by time 30 seconds, we get value is equal to 0. So this statement is also correct. Third statement, the average velocity of object is 0. So average velocity, we cannot say the average velocity of object will be 0, as the average velocity will be definitely greater than 0. The average velocity will be equal to 0 if we take the average of this curve, and it will be lie on this line, but the average of this line clearly lies above this time axis, so this is false. And the average force on the object will be 0 for this time interval 0 to 30 seconds. So as the acceleration, average acceleration for this object will be 0, so the average force, which is equal to m into a, and it must be equal to 0. So answer this D will also be correct. Problem is that the displacement of a body of mass 2 kg varies with time t as s is equal to t square plus twice t, where s is in meter and t is in second. The work done by all the force acting on the body during the time interval t is equal to 2 to t is equal to 4 seconds. Again, from this problem, you may also easily infer that this problem should be solved by using work energy theorem, as the displacement is given in respect of time t. So if we differentiate the displacement, we get the velocity, and the work done will be equal to change in kinetic energy as per work energy theorem. So ds by dt is equal to twice t plus 2, and this is equal to velocity. So velocity is at t is equal to 4, that is at time t is equal to 4 seconds, we get equal to 10 meter per second, and velocity at t is equal to 2 will be equal to 6 meter per second. So the change in kinetic energy will be equal to half m v square minus u square, and is equal to 1 by 2 into value of m is 2, and it is equal to 100 minus 64, 100 minus 36. So it's equal to 1 by 2 into 2 into 64, and the value comes equal to 64 joule. So the work done by all the force acting on the body during this time interval t is equal to 2 to 4 seconds will be equal to 64 joule. So we have seen a lot of problem based on the work energy theorem, so it's a very important concept and you should keep in mind. Again, we will see next problem from the EMS 2010, and basically it's a good problem that a block of mass 10 kg is moving in x direction with constant speed of 10 meter per second. It is subjected to a retarding force of F equal to minus 0.1 x joule per meter during its travel from x is equal to 20 meter to 30 meter. The final kinetic energy will be. So again, as per the work energy theorem, W is equal to change in kinetic energy. So the initial kinetic energy will be Ki is equal to half mu square. If we consider u as the initial velocity, so initial speed was given as 10 meter per second and block of mass is 10 kg. So we get Ki is equal to 10 into 10 into 10 divided by 2, and the value is equal to 500 joule. So this is our initial kinetic energy. We have to calculate the final kinetic energy, and for this we first calculate the work done during its travel from x is equal to 20 meter to x is equal to 30 meter. Again, if you see this force, then force is not constant, it depends on the x. So force depends on the position. So what we will do, we will use the concept of calculus and consider that object is at an arbitrary distance x and makes an infinitesimal small displacement equal to dx, and the work done in this infinitesimal displacement will be given as dw. It's equal to f dot dx, and its value is equal to minus 0.81 x into dx, and the work done will be equal to integration of this, so minus 0.1 x dx and the limit will be that x, it travels from x is equal to 20 meter to 30 meter. So 20 to 30, the limit of x is 20 to 30. So minus 0.1 into x square by 2, limit will be 20 to 30, and minus 0.1 divided by 2 into 900 minus 400, and minus 0.1 into 500 divided by 2. So basically it comes equal to minus 25 joule. So now, as per this work energy theorem, W is equal to kinetic energy, and on the left hand side W is equal to minus 25 joule. On the right hand side, change in kinetic energy, that is K final minus K initial, and K final comes equal to minus 25 plus K initial, and K initial is equal to, we have calculated 500 joule. So 500 minus 25, and the value comes equal to 475 joule. So this is also an example of work energy theorem. And if you see this problem, then this force is not constant force. This force is not conservative force. It's basically a non-conservative force, and we have already learned that the work energy theorem is true for conservative as well as non-conservative force. So answer will be 475, that is A.